If a civilization is advanced enough, they could build a gigantic structure around a star to harness its entire energy output. But is that even possible? In 1964, physicist Nikolai Kardashev proposed a system for classifying civilizations based on their energy consumption. A Type 2 civilization could harness the full energy output of a star, and that's where the Dyson Sphere comes into play. Freeman Dyson once asked, "If there is an advanced civilization out there, how could we detect them?" He proposed that a highly developed civilization might surround a star with a massive energy harvesting system, emitting detectable infrared signals. When you hear about a Dyson Sphere, you might imagine a gigantic solid shell surrounding a star. But in reality, it doesn't have to be a single structure. A Dyson Sphere could exist as a massive ring, a network of satellites, or even millions of mirrors reflecting the star's light. A solid Dyson Sphere is nearly impossible, as gravitational forces would make it collapse. But what if, instead of a solid shell, we used millions of small satellites orbiting the star? This is the concept of the Dyson swarm, the most feasible model. A Dyson Sphere could provide nearly unlimited energy, pushing a civilization further up the Kardashev scale. Energy is the key to any civilization's progress. As energy demands grow, harnessing a star's power could push a civilization to Type 2 on the Kardashev scale, marking a monumental leap in cosmic evolution. Right now, humanity is far from being a Type 2 civilization. We lack the technology to mine resources at an enormous scale or construct megastructures around a star. But in the next few centuries, with more advanced technology, this dream might become a reality. Instead of building a massive sphere around a star, a more realistic solution is the Dyson swarm, a system of millions of small satellites orbiting the star to collect its energy. Without needing a solid structure, Dyson swarm is more flexible, easier to build, and still delivers massive energy output. Even with the right technology, building a Dyson Sphere would be an enormous challenge. We would need to gather massive amounts of raw materials, transport them into space, and maintain the stable orbits of each component. Not to mention the thermodynamics problem. How do we manage the immense heat from the star? A megastructure like the Dyson Sphere would require more material than Earth could ever provide. The only solution is space mining, harvesting resources from asteroids or even unused planets in the star system. If we could mine an entire rocky planet the size of Mars, we might have enough material to build a Dyson swarm. Transporting millions of tons of material into a star's orbit and assembling them into a Dyson swarm would require a network of automated robots and advanced AI. These machines would need to operate in harsh space conditions where even the smallest error could lead to catastrophe. A Dyson Sphere collects an enormous amount of energy, but the biggest challenge is transmitting it where it's needed. There are two main methods: radio wave transmission or high-energy laser beams sent to a receiving station on a planet. But each method has its risks. Even though it's more feasible than a Dyson Sphere, a Dyson swarm still presents major challenges. We would need millions of giant satellites, materials durable enough to withstand the harsh environment of space, and a precise control system to maintain their orbits. To build a Dyson Sphere, we would need an enormous amount of material, more than the total mass of Earth. That means humanity would have to mine resources from other planets, asteroids, or even extract material from a gas giant. A Dyson Sphere would collect billions of terawatts of energy, but how do we send it back to Earth? We could use microwave beams or lasers, but this comes with significant risks. Some scientists suggest that the first step would be mining near-Earth asteroids, then expanding to the solar system. Building automated space stations and using robots would optimize the process. To construct a Dyson Sphere, we would need advanced space mining technology, automated manufacturing in space, ultra-light yet durable materials, and artificial intelligence to manage the entire system. Today, many of these technologies are still in their early stages of development. A Dyson Sphere would provide nearly limitless energy, ushering in a new era of technology, science, and space travel. It could enable humanity to colonize other planets and become a Type 2 civilization. Astronomers have been searching for unusual infrared signals in space, Potential evidence of an alien Dyson sphere. Some stars, like Tabby's star, have puzzled scientists, leading to speculation about the existence of massive structures around them. Perhaps advanced civilizations have built Dyson spheres, but intentionally hide them, or maybe we're just not looking in the right direction. It's also possible that even for a Type 2 civilization, building a Dyson sphere is too challenging. Some estimates suggest that if humanity developed the necessary technology, we could build a Dyson swarm in a few centuries. However, completing a full Dyson sphere might take thousands of years. Building a full-scale Dyson sphere could require materials equivalent to hundreds or even thousands of Earth-sized planets. We might need to mine asteroids, strip mine planets like Jupiter or Saturn, or even dismantle entire planets to gather enough resources. A Dyson sphere could be distorted or even pulled into the star by its gravitational force. A more practical solution is the Dyson swarm, a system of satellites orbiting the star instead of a solid shell. A Dyson sphere would absorb immense heat. Without an effective cooling system, it could melt or turn into a massive reactor. Some theories suggest using reflective mirrors or radiating excess heat into space. Every structure on Earth relies on solid foundations, but a Dyson sphere has none. Without precise balance, it could drift and fall into the star. One approach is to use space propulsion systems to maintain a stable orbit. Space is filled with drifting asteroids. A collision with a large asteroid could seriously damage a Dyson sphere, or even destroy parts of its structure. How can we protect it? The Dyson sphere is massive, yet incredibly fragile. A design flaw, a small impact, or structural imbalance could bring the entire system crashing down like a cosmic domino effect. A complete Dyson sphere would absorb all the light from the star, leaving surrounding planets in perpetual darkness. This could turn an entire planetary system into a dead zone. If a Dyson sphere were equipped with massive propulsion systems, it could create stellar engines, cosmic thrusters capable of moving a star. This might be how an advanced civilization relocates an entire planetary system to avoid cosmic disasters. A Dyson sphere wouldn't emit visible light, but it would radiate strong infrared signals. Scientists have searched for such signs in space, but no clear evidence has been found. Could there be an advanced civilization using a Dyson sphere right now? With our current technology, humanity is not yet capable of building a true Dyson sphere. But with advancements in autonomous asteroid mining, fusion energy, and advanced AI, this dream could become a reality in the distant future. A Dyson sphere doesn't always have to be a fully enclosed structure. In fact, the most practical design might be a Dyson swarm, a network of millions of independent satellites orbiting a star, collecting energy without requiring a massive physical structure. Another variation is the Dyson ring, a circular array of solar collectors similar to planetary orbits. However, a complete Dyson sphere that fully encases a star remains the most ambitious vision. To build a Dyson sphere, we would need ultra-durable materials capable of withstanding the immense heat of a star. Additionally, assembling a megastructure spanning millions of kilometers is unprecedented. Another major issue is gravity. A fully enclosed Dyson sphere would be gravitationally unstable and could collapse due to the pull of the star. This is why many scientists believe that Dyson swarms or Dyson rings are far more feasible designs. Right now, humanity lacks the technology to extract and transport materials on an interstellar scale. However, with advancements in artificial intelligence, autonomous robotics, in space mining, the idea of building a Dyson sphere isn't as far-fetched as it once seemed. The first steps might involve harvesting solar power with orbital satellites before expanding into Dyson swarm systems in the future. A fully constructed Dyson sphere would absorb most of the light from its host star, but still emit infrared radiation due to excess heat. This is a signal that our telescopes could potentially detect. Astronomers have searched for partially obscured stars or unusual thermal emissions, but so far, no clear evidence of a Dyson sphere has been found in the universe. However, that doesn't mean they don't exist. The Milky Way contains hundreds of billions of stars, and if even one Type 2 civilization exists, they might have built a Dyson sphere. Some studies suggest that certain unusual thermal emissions could come from such structures. But if Dyson spheres exist, why haven't we found clear evidence? Could they be deliberately hiding their presence? If the Dyson sphere is the most efficient way to harness energy, why haven't we built one yet? There are two main reasons: technology and resources. We currently lack the advanced technology to construct such a massive structure in space. Additionally, building a Dyson sphere around the sun would require an enormous amount of material, potentially equal to the mass of Mercury or Mars. But if humanity advances to Type 2 on the Kardashev scale, this could become a reality. Instead of constructing a single massive structure around a star, the Dyson swarm consists of millions of energy-collecting satellites orbiting the sun in various trajectories. This concept is far more feasible, as it doesn't require an enormous amount of material like a traditional Dyson sphere. Some scientists believe this is the most realistic way for humanity to harness stellar energy. To deploy a Dyson swarm, we need autonomous robots, space-based 3D printing, and artificial intelligence to coordinate millions of satellites. Additionally, mining resources from asteroids or the moon could provide the necessary materials without launching them from Earth. If these technologies advance rapidly in the 21st century, the Dyson swarm may no longer be science fiction. Could humanity become a Type 2 civilization? If the Dyson swarm becomes a reality, humanity will take a major step toward becoming a Type 2 civilization. Harnessing energy directly from the sun could provide an unlimited power source for space exploration, constructing massive space stations, and even interstellar travel. Dyson sphere, science fiction or humanity's inevitable destiny? The idea of a Dyson sphere may sound like science fiction, but history has shown that today's technology was yesterday's impossibility. If humanity keeps advancing, perhaps one day we will build a massive system to directly harness energy from the stars. When that day comes, will we be the conquerors of the cosmos, or just another step in the grand evolution of life?